Today I shall explain humidity and precipitation and different components related to humidity and the different types of humidity and precipitation. Humidity in the air is the content of water vapor available in the air at a specific time and place. The presence of water vapor in the atmosphere varies both spatially and temporally. At some places it is 0 and at other places it is 5%. Most of the atmospheric water vapor is concentrated in the lower atmosphere of the earth. Around 50% of vapor remains below 2000 meters. Water vapor is very important factor for influencing the weather condition of a place. Precipitation, loss of heat, surface temperature, latent heat of the atmosphere, stability and instability of air masses all depends on the amount of water vapor present in the atmosphere. The source of atmospheric water vapor is the evaporation that occurs from water bodies on the earth like oceans, seas, lakes, rivers, ponds, etc. Evaporation is the transformation of liquid into gases. According to the prevailing aridity, temperature and velocity of winds, the intensity of evaporation goes up or down. When water vapor turns into liquid and solid form, that process is known as condensation. Now let me explain what is latent heat. Latent heat is the heat released or absorbed during phase change. Latent heat characteristic amount of energy absorbed or released by a substance during a change in its physical state that occurs without changing its temperature. The latent heat associated with melting of a solid or freezing a liquid is called the heat of fusion. That associated with vaporizing a liquid or a solid or a condensing a vapor is called the heat of vaporization. The latent heat is normally expressed as the amount of heat in units or joules or calories per mole or unit mass of the substance undergoing a change of a state. For example, when a pot of water is kept boiling, the temperature remains at 100 degrees centigrade until the last drop evaporates, because all the heat being added to liquid absorbed as latent heat of vaporization and carried away by escaping vapor molecules. Similarly, while ice melts, it remains at 0 degrees centigrade, and the liquid water that is formed with the latent heat of fusion is called at 0 degrees centigrade. The hidden amount of heat in water vapor is called latent heat. Heat energy is released at the time of condensation, and this energy is known as latent heat of condensation. Now I will explain you humidity capacity. The atmospheric humidity is obtained from the process of evaporation. Various climatic activities occur due to atmospheric humidity. We express atmospheric humidity broadly in 3 ways: absolute humidity, specific humidity and relative humidity. The moisture content of the air is measured in grain per cubic foot or in gram per cubic centimeter. Evaporation is the main mechanism through which water is converted into vapor. Since temperature and evaporation are directly positively related, I meant to say evaporation increases with increasing temperature and hence humidity and temperature are also directly positively related. The moisture retaining capacity or humidity capacity refers to the capacity of an air of certain volume at certain temperature to retain maximum amount of moisture content. Humidity capacity is directly positively related with temperature, as I mentioned earlier. Example, higher the temperature, higher the humidity capacity. In other words, as air temperature increases, humidity also increases and vice versa. This is the reason humidity capacity becomes higher during summer months, then winter months, and during daytime, then nights. The extent of land and water and wind velocity also influences humidity capacity. Oceanic and coastal areas record higher humidity capacity of all air than remote areas of the continents. Humidity capacity decreases from equator to poleward. The air having moisture content equal to its humidity capacity is also called saturated air. Now you may be thinking, what is absolute humidity? The actual amount of the water vapor present in the atmosphere is known as the absolute humidity. It is the weight of water vapor per unit volume of air, and it is expressed in terms of grams per cubic meter. The absolute humidity differs from place to place on the surface of the earth. The ability of air to hold water vapor depends entirely on its temperature. Warm air can hold more moisture than cold air. The absolute humidity decreases from equator towards the pole and from ocean to the continent. The possibility of precipitation largely depends on absolute humidity. Specific humidity. Now, what is this specific humidity? It is expressed as the weight of water vapor per unit weight of air, or the proportion of the mass of water vapor to the total mass of air. Since it is measured in units of weight, usually grams per kilogram, the specific humidity is not affected by change in pressure or temperature. It is directly proportional to vapor pressure, which is the partial pressure exerted by water vapor in the air and is independent of other gases, and is inversely proportional to air pressure. Specific humidity decreases from equator towards pole. For example, extremely cold and dry air over Arctic region during winter generally has a specific humidity of 0.2 gram per kilogram of air, while it becomes as high as 18 gram per kilogram of extremely warm and moist air over equatorial regions. In a real sense, specific humidity is a geographer's yardstick of a basic natural resource, water, to be applied from equator to polar region. It is a measure of the quantity of water that can be extracted from the atmosphere as precipitation. This phenomena was explained by A.N. Stoller and A.H. Stoller in 1978. What is relative humidity? Let me explain you. Relative humidity is defined as a ratio of the amount of water vapor actually present in the air having definite volume and temperature. Example, absolute humidity, to the maximum amount of air that can hold. In other words, relative humidity is the proportion of absolute humidity of an air of a definite volume at a given temperature to the humidity capacity of that air. So, relative humidity is generally expressed as percentage. For example, if the humidity capacity and absolute humidity of air having temperature of 20 degree Celsius are 8 grams and 4 grains per cubic foot respectively, then the relative humidity will be, you may calculate it, relative humidity will be equal to absolute humidity divided by humidity capacity. That means 4 divided by 8 into 100, and that will be equal to 50%. Or in other word, if we see the ratio, then it will come as a 1:2. There is an inverse relationship between air temperature and relative humidity. Example, relative humidity decreases with increasing temperature, while it increases with decreasing temperature. You may refer this table for understanding what am I explaining to you, whether it is relative humidity or specific humidity. You may understand taking this table as a reference. When the humidity capacity and absolute humidity of the air are the same, the air is said to be saturated and relative humidity becomes 100%. Relative humidity changes in two ways. For example, the first, if the absolute humidity increases due to additional evaporation, or the second circumstances is if the temperature of the air decreases so that humidity capacity also decreases. For example, the relative humidity of the air with 50 degree F temperature is 46%, because humidity capacity and absolute humidity are 4.1 grains and 1.9 grains respectively. But if the air temperature of that air decreases due to ascent of to 40 degree, the relative humidity becomes 65.5%, because the humidity capacity decreases to 2.9 grains per cubic foot. What is the significance of relative humidity? Relative humidity has a great climatic significance because the possibility of precipitation depends on it. High and low relative humidity is indicative of possibility of wet, in the sense precipitation, and dry conditions respectively. The amount of evaporation also depends on relative humidity. Evaporations decreases with high relative humidity, while it increases with low relative humidity. Relative humidity is directly related to human health and comfort. For instance, very high 60% and very low humidity is injurious to human health. This is why the equatorial region with high temperature and high relative humidity and tropical region such as hot deserts with very low relative humidity and tropical hot desert with very low relative humidity are very harmful for human health. Relative humidity also affects the stability of different objects, buildings, electrical appliances, radio, etc. I would like to explain the distribution of relative humidity. The horizontal distribution of relative humidity on the Earth's surface is zonal in character. Equatorial regions are characterized by highest relative humidity. It gradually decreases towards subtropical high pressure belts where it becomes minimum, somewhat between 225 degree to 35 degree latitude. It further increases polewards. The zone of high and low relative humidity shift northward and southward migration of sun respectively. Seasonal distribution of relative humidity is largely controlled by latitudes. Maximum relative humidity is found during summer season, between 30° north and 30° south latitude, while high latitude record relative humidity more than average value during winters. There is maximum relative humidity in the morning, where the lowest value is recorded in the evening. What is evaporation? So, evaporation is a process by which water is transformed from liquid to gaseous state. The oceans contribute 84% of the annual total and the continent 16%. The highest annual evaporation occurs in the subtropics of western North Atlantic and North Pacific because of the influence of Gulf Stream and the Kuroshino current and in the trade winds zone of the southern oceans. The land maximum occurs in equatorial regions because of high insolation and luxuriant vegetation. Now, what could be the factors affecting rate of evaporation? That may be the first, amount of water available, second may be area of evaporating surface, third is temperature, and fourth is relative humidity. So, air with low relative humidity has more space for moisture and hence evaporation increases. Wind can be the fifth factor. Movement of air replaces the saturated layer with unsaturated layer. Hence, greater wind speed, the greater is the evaporation. Whenever there is a combination of high temperature, very low relative humidity and strong winds, the rate of evaporation is exceptionally high. This leads to dehydration of soil to a depth of several inches. The sixth factor may be air pressure. Evaporation is also affected by atmospheric pressure exerted on the evaporating surface. Lower pressure over open surface of the liquid results in higher rate of evaporation. Apart from that, composition of water. Evaporation is inversely proportional to salinity of water. Rate of evaporation is always greater over fresh air than over salt water because of the reduction in the vapor pressure and ability of water molecules to bounce off the surface at the water surface due to salinity. Under similar conditions, ocean water evaporates about 5% more slowly than fresh water. So, you should understand the difference of evaporation over the fresh water compared to the oceanic water. More evaporation by plants. Water from plants generally evaporates at a faster rate than from lands. Now, I will explain condensation. The transformation of water vapor into water is called condensation. Condensation is caused by the loss of heat. Latent heat of condensation, opposite of latent heat of vaporization, which I explained earlier. How? When moist air is cooled, it may reach at a level when its capacity to hold water vapor ceases. I mean to say, it is actually a saturation point. So, what is the saturation point? Saturation point is equal to 100% relative humidity, or we also called as dew point. That is what I was explaining, this 100% relative humidity earlier, before I explained this condensation. So, when it reaches to the dew point, then the excess water vapor condenses into liquid form. If it directly condenses into solid form, it is known as sublimation. You may see this figure and you will know what am I explaining. Phase change in free air condensation results from cooling around very small particles termed as hygroscopic condensation nuclei. Particles of dust, smoke, pollen and salt from ocean are particularly good nucleus because they absorb water. Condensation also takes place when the moist air comes in contact with some colder object, and it may also take place when the temperature is close to the dew point. Condensation therefore depends upon the amount of cooling and the relative humidity of the air. Condensation takes place because of different factors. First is when the temperature of the air is reduced to dew point with its volume remaining constant, that is known as adiabatically, or we can say adiabatic cooling. The second is when both volume and temperature are reduced, bring down saturation temperature. The third condition is when moisture is added to the air through evaporation, that increases in relative humidity. After condensation, the water vapor or the moisture in the atmosphere takes one of the following form. It may be dew or frost, fog and clouds. So, condensation takes place when the dew point is lower than the freezing point as well as higher than the freezing point. Now, we will explain the processes of cooling for producing condensation adiabatic temperature changes. When the air rises, it expands. Thus, heat available per unit volume is reduced and therefore, the temperature is also reduced. Such a temperature change which does not involve any subtraction of heat and cooling of air takes place only by ascent and expansion, that is termed as adiabatic change. The vertical displacement of the air is the major cause of adiabatic and katabatic. In other words, we say cold dense air following down a slope, that temperature changes. Near the earth's surface, most processes of change are non-adiabatic. Why? Because horizontal movements often produces mixing of air and modifies its characteristics. And as I mentioned, in adiabatic change, you need to have a vertical characteristic. Non-adiabatic temperature change. Non-adiabatic processes include cooling by radiation, conduction or mixing with colder air. The air may be cooled due to loss of heat by radiation. The non-adiabatic processes of cooling produces only dew, fog or frost. They are incapable of producing a substantial amount of precipitation. In case there is direct radiation from moist air, the cooling produces fog or clouds, subject to presence of hygroscopic nuclei in the air. Cooling by contact with a cold surface produces dew, frost or fog depending on other atmospheric conditions. What are different forms of condensation? The forms of condensation can be classified on the basis of temperature at which the dew point is reached. Condensation can take place when the dew point is first lower than freezing point or the higher than the freezing point. White frost, snow, hailstones and some clouds are produced when the temperature is lower than the freezing point, whereas dew, fog and clouds results even when the temperature is higher than the freezing point. Forms of condensation may also be classified on the basis of their location. For example, at or near the earth's surface and in free air. Dew, white frost, fog and mist come in the first category, whereas clouds are in the second category. Now, what is dew? When the moisture is deposited in the form of water droplets on cooler surface of solid object rather than nuclei in the air above the surface, such as a stone, grass blades or plant leaf, it is known as dew. The ideal condition for its formation are clear sky, calm air, high relative humidity and cold and long nights. For the formation of dew, it is necessary that the dew point is above the freezing point. Now, let me explain you why frost. Frost forms on cold surface when condensation takes place below freezing point, that means 0 degree centigrade, below the freezing point, that is called as white frost. The excess moisture is deposited in the form of minute ice crystal, very minute ice crystals instead of water droplets. The ideal condition for the formation of white frost are the same as those for the formation of dew, except that the air temperature must be at or below the freezing point. You may refer this particular picture which is depicting the white frost. The next one is fog. When the temperature of an air mass containing a large quantity of water vapor falls all of a sudden, mostly due to temperature inversion, condensation takes place within itself on the fine dust particle. So, the fog is a cloud with its base at very near to the ground. Because of the fog and mist, the visibility becomes poor to zero. In urban and industrial centers, smoke provides plenty of nuclei which helps the formation of fog and mist. Such condition when fog is mixed with smoke is described as smoke. Radiation fog results from radiation, cooling of the ground and adjacent air. These fogs are not very thick and are usually in winters. Fogs formed by condensation of warm air when it moves horizontally over cold surface are known as advectional fog. These fogs are thick and persistent. Occurs over warm and cold water mixing zone in oceans. Now, after that I will explain what are the frontal or precipitation fog. The precipitation fog is produced due to convergence of warm and cold air masses, where warm air mass is pushed under the heavier cold and air mass. Precipitation in warm air mass condenses to produce fog at boundary of two air masses. These are called frontal or precipitation fog. In fog, visibility is less than 1 kilometer. Now, after understanding fog, you should understand the difference between the mist and fog. So, what is mist? The difference between mist and fog is that mist contains more moisture than fog. In mist, each nucleus contains a thicker layer of moisture. Mists are frequent over mountains as the rising warm air up and slopes meet a cold surface. Water droplets also form mist, but with less merging or coalescing. This means mist is less dense and quicker to dissipate. Fogs are drier than mist, and they are prevalent where warm currents of air comes in contact with cold currents. In mist, visibility is more than 1 kilometer, but less than 2 kilometers. You may refer this figure and may understand what am I talking. Now, after understanding mist, you may be thinking, then what is the smoke? Smog, you can say that it's a mixture of a smoke and fog. We also refer it as a smoky fog. This is caused by burning of large amount of coal, vehicular emission and industrial fumes. These are also known as primary pollutants. So, smog contains soot particulates like smoke, sulfur dioxide, nitrogen dioxide and other components. At least two distinct types of smoke are recognized. One is sulfurous smog and photochemical smoke. So, this picture explains the sulfurous and photochemical smoke. These days, we all are witness of extreme climatic conditions, not spatially but temporally also. Every year, we may see the occurrence of extreme precipitation, or many parts of our own country as well as world, we are facing the drought-like conditions. So, before understanding these extreme climatic conditions, it was very important for all of you to understand humidity, relative humidity, absolute humidity, what are the distribution of humidity, what is the significance of humidity, what is the bad and good impact of humidity, and how it is important, or in other words, I can say that how crucial it is to balance the humidity, to balance the natural cycle, and that is how we can actually contribute to maintain our own life, not only for ourselves but also for our next generation.